Section 1.5 is the distributive property. So the distributive property says for any numbers a, b, and c, a times parentheses b plus c, we can distribute to get ab plus ac, and the same thing works with subtraction. Oops, that should say minus. So we have a times b minus a times c. And you guys have all used this before, so this is kind of review. So the distributive property. Let's look at an example, and you should copy this into your notes, so pause. You want to purchase 4 movies costing $14 each and 4 books costing $8 each. How much is the total cost of the movies and the books? So there are 2 ways to do this problem, and it involves the distributive property. First of all, I could say, well, 4 movies costing $14 each is 4 times 14. Let me pick a better color for this. All right, 4 times 14 plus 4 books costing $8 each. So that's one way to write this problem, but you look and see that both of these numbers are being multiplied by 4. So we could say 4 times 14 plus 8. Both of these methods will work. So which one's going to be the easier for us here? So to figure out 4 times 14, I got to do a little math. I'm going to get 56. Whoops. Plus 4 times 8 is 32, and then I'm going to add those together, and I will get 88. If I do it this way, adding 14 plus 8 is 22, and I will still get 88 with my multiplication. So sometimes the distributive property helps us work a problem a little bit easier. For me, multiplying 4 times 14 is harder than multiplying 4 times 4 times 22. So that's using our distributive property. We can also use the distributive property to solve and to simplify mental math problems. So again, 15 times 99, I might have to work that off to the side, but if I change my 99 to be 100 minus 1, that's still 99, and then I distribute 15 times 100 minus 15 times 1. Now I have 1500 minus 15, and I can do that fairly simple because I know that 100 minus 15 is 85, and I can get 1485. Let's try another one like this. Well, can't get my screen to move. Let's see what's going on. Okay, so 32 times 2.1. So again, 2.1 could cause me some trouble. But if I do 35 times 2 plus 0.1, 35 times 2 is 70. 35 times 0.1, I just have to move the decimal point, and I'll get 73.5. We'll do a few more of these together in class, but I hope you can see how the distributive property can make things a little easier sometimes. Okay, the next thing I want to look at is applying the distributive property to algebraic expressions. So for example, 5 times g minus 9. If I distribute this, I will get 5g minus 5 times 9 is 45. So this is simplified because I no longer have my parentheses. Try the same thing with this one. Write it down, take a moment and pause, and try it yourself. Okay, so hopefully you did 3 times 2x is 6x, and 3 times 4 is 12. All right, let's carry on. Term. A term is a number, a variable, or a product or quotient of numbers and variables, not a sum or difference. In other words, the numbers and variables can be joined by multiplication or division, but not addition or subtraction. So for example, 3x is a term. It's 3 and x being multiplied together. 12 divided by 3x is a term. However, 3 plus x is not a term, and 3 minus x is not a term. So the terms here are the ones that when we have multiplication and division as the operation. You can use the distributive property to combine like terms. Again, let's look at an example here. So 5n plus 7n. You notice that the n is in common, so I can pull that out as a distribute, because remember, n times 5 is 5n, n times 7 is 7n. And so by doing that, I know that I'm multiplying the 5 plus 7 to get 12 times n. And again, we will do a few more of those together in class. Equivalent expressions. Equivalent expressions are ones that represent the same number. And we get equivalent expressions by simplifying. So our simplest form is when there are no like terms and no parentheses. So for example, if I have 3n plus 4n, those are like terms and I want to combine them. A lot of the times you can do this just with mental math, because 3 plus 4 is 7. Using our distributive property, this would be n times 3 plus 4, which is n times 7, which again we write as 7n. So simplest form means we have to combine our like terms. So 3n plus 4n is an equivalent expression with 7n. The coefficient is the numeric portion of the term. So here's a term, my 3n. The coefficient here would be 3. If I have something like 17xy squared, the coefficient is the numeric portion, the 17. If I have 3x over 4yz, again, the numeric portion is 3/4. That's my coefficient. What about this one? This is a term. What would the coefficient be? What's the number in front? If you remember from our identity property, 1 times m is the same as m, so the coefficient here is 1. The coefficient of m is 1. Okay, that should be enough to get us started. We'll go over notes and answer any questions in class.